Hello trig class, it's October already and it's October the 1st, it's Thursday evening when you'll be watching this, or at least late afternoon. Let's look at the sine and cosine curves again. These are mimicked in nature, or we could say sine and cosine curves mimic nature. Let me show you a relaxing curve. Here it is. You can hear what it is before I can get the camera on it. Alright, these are waves, and that's what a sine and cosine curve is. They're waves. Here's some gentle waves. These waves have amplitude and they have period, just like the ones we've studied so far. Alright, let me show you some waves that have a little higher amplitude than these waves. Let me get that going and up. Okay. Alright. Turning off all my wave sounds in the world. Alright, back we are here on sine and cosine curves, which are nothing but waves, just like the ones in the ocean. And here we have a way to describe them. The amplitude of the gentle waves is a lot smaller at this number than the amplitude of those big waves we just witnessed. And here is the position that talks about how high the amplitude is. That is how much different from the center of the wave to the highest point. That's the amplitude. And then B talks about the period, which is basically how long does it take for the whole cycle to take place. One mountain and one valley. And here we can see that it's the same for cosine and sine. So just as a refresher, I'll go over an example of those two from last time. And this one is y equals 3 sine x over 2. I put an x in our problem, and this can be replaced with theta. So you should be able to use either. That just represents the angle, the variable of the angle. So in this one, I'm going to rewrite it, and when I get to x over 2, I'm going to call it 1/2 x, so I can easily define what b is. So a is 3, and b is 1/2. A is easy peasy because the amplitude is just given by whatever a is. We don't have to mess with it. But b is a little sneakier. You have to know a little formula, and the key is that b is always equal to 2 pi divided by the period. So b has the secret of the period in it, but it doesn't come right out and tell you. Makes you work for it. So we solve this for p by multiplying both sides by p and dividing, b is known. It's 1/2. We got it from right there in that position. So when I multiply both sides by p, I get 1/2 p equals 2 pi. Now I divide both sides by 1/2, and we know when we divide by a fraction, it's like multiplying by the reciprocal. So we get p equals, the period is 4 pi. Right. let's graph that one, and because now we know the period is period equals 4 pi, and the amplitude is 3. So we'll use those two pieces of data to get our graph. The regular sine curve will start here, peak at 1, bottom out at -1, and do all that peak and valley in 2 pi radians. So that's going to change. That's not the answer to this one, because this is going to go up 3 from the center line. I'll make that a 3, and down 3. And then is period. This whole peak and valley operation is going to have to take place in 4 pi radians. So I'm going to change my horizontal axis to reflect that. When it's 4 pi, I'll go 1 pi, 2 pi, 3 pi, 4 pi. So I want one peak and one valley going up to 3 and down to -3 within 4 pi radians. So that's one cycle, and you understand that it's going to go on in both directions in the same way. Grading one cycle is a lot easier though. So if you just give me one cycle and indicate that it goes on forever. All right, over here, the difference is it's a cosine curve, and I did put a negative in to remind you what that is. The amplitude is still 2, and let's see what the secret information is. We know b equals 2 pi divided by the period. So b is 3 in this case. Solving that, we get 3 times p equals 2 pi. Divide, and we get period is 2 pi over 3. So I'll give myself some good room here this time. So the amplitude is 2, and the period is 2 pi over 3. And we have to remember that this is a negative cosine curve. All right, so to draw that up, I start and I'm going to go up to 2 and down to -2 this time. And 2/3 pi, if I call this pi about 2/3 of the way over, I'll call that 2/3 pi. So my graph normally starts on cosine at the top of the wave, but because we have a negative curve, it's going to flip and what we call reflect across this axis. So what was up is now down. So I'm going to start here, and I've got to get a whole peak, and well, cosine curve starts low, goes high, and ends up down low when it's inverted like that. So actually I have a peak here and half a valley on each side, which equates to one peak and one valley. I'll try to show that they end in the same spot like that. All right, so you were working on ones just like that in class the other day, and today I'm going to add some more variations to our sine and cosine curve. So y equals, we had a sine b, and I'm going to add to it the variable x minus c. This minus c, which I put in here, is going to move the curve right and left. So it's a horizontal shift. And that horizontal shift or translation is interpreted like this. When it's a negative number here, then that would be a negative number is going to move the object to the right. Sort of, it's not very intuitive. You would think a negative number would move it to the left, but it does not. And a positive number in the C position will move it to the left. So let's do one and see how that works. I'm going to do y equals 1/2 sine x minus pi over 3. And so we're going to look at all three spots. This is my A spot, this is my B spot, and this is my C. So the A is the amplitude. So I'm going to go up to 1/2 and down to minus 1/2 at the highest part of the wave and at the lowest part of the wave. My b is just a 1, so the period is unchanged. It's the normal period of 2 pi radians. So if I was just going to sketch it without the c change, I would start here with the positive sine curve, go up to 1/2. Let me dot this in, it's not the real answer. Go down to negative 1/2 and end up at 2 pi, 1 peak and 1 valley. So what does the pi over 3 do? Well, as I said, a negative number will shift it to the right, pi over 3. So I have to kind of guess or estimate more where pi over 3 is. So if this is pi, I would say 1/3 of the way over to pi is going to be pi over 3 is about right there. So if I'm going to move everything over pi over 3, I'm going to do it in 4 different points. I'm going to take 1, 2, 3, 4, and then I'll go ahead and repeat. I'll do that one as well. 5 different points. So I'm going to move each of them pi over 3 over. So when I move this one over, it's now here. I'm going to mark it with a little X instead of a circle or a dot. This one is going to go over the same amount. Looks like about that much. This one's going to go over same amount. This one and this one. All right. So now if I connect all of those X's, I have a curve that is shifted from my dotted one by pi over 3 to the right, and that will continue so on. You see how the darkened curve is a shift to the right of pi over 3. All right, that's how you handle that one. Let us try one where we have another change. I better shut down. I'm not sure how many minutes I've been talking, so I don't want to go over. So I'll see you in part 2 for our last example.